Consider any linear operator S in the algebra A of B. Now you note that S can be written in this form A plus IB, where A is this operator and B is this operator. S plus the Hermitian adjoint of S divided by 2. Divided by 2 means we are multiplying this sum by 1 divided by 2, that's all. Similarly, B is S minus its Hermitian adjoint divided by 2i. It's a simple thing to check that if you use A and B here, then you get S. But what is so special about this A and B? By using lemma 610(4), we find that the Hermitian adjoint of A is A itself. It is that lemma where we have the basic properties of Hermitian adjoint. So let's see the steps. We are calculating A star, that means the star of this. What is this actually? This is actually the scalar multiplication operation where we have multiplied the operator S plus S star by the scalar 1 divided by 2. So one of the properties of star from this lemma tells us that we can take the complex conjugate of 1 divided by 2 outside of this star. Because 1 over 2 is a real number, so just that comes out. That is why we have a 2 here in the denominator. And along with that, we have the star of S plus S star. And then another property tells us that we can then write it like this. Star gets inside the sum and gets applied to each operator in the sum. So that's how we have S star plus S star star. And then one more property tells us that this is equal to S. Because addition of operators is commutative, so this is just A. So you have found that A is self-adjoint or Hermitian. Similarly, can we say something about B? Similarly, B star is the star of S minus S star divided by 2i. This time, however, because 2i is not a real number, so its complex conjugate, when you use that property which comes out, is minus 2i. And then with that, in the numerator, you have S minus S star star. And then star again gets pushed inside. But this is, in spite of this being a difference, by definition, actually it's a sum. It's the sum of the operators S and minus S star. So ideally, you should write one more line where you first write S star and then you write plus star of minus S star. And then that minus S star is actually minus 1 times S star. That's also a product where you are multiplying S star by the scalar minus 1. So from that star, from the star of that, if you take minus 1 outside, then actually its complex conjugate comes out. But that is a real number. So that's how just minus 1 comes out. So that means you are having here minus 1 times S star star. But that you already know equals the negative of this operator. And then here you can again use that property that this is equal to S. Now note that here, unlike this one, you are getting S star minus S. That's not exactly equal to S minus S star. However, you already have a minus in the denominator. So things get adjusted and you again get B. So yes, B is also Hermitian or self-adjoint. And we write the conclusion here. So A and B are both Hermitian. But because B is Hermitian, IB is skew-Hermitian, which you can easily check using again properties of star. And that is why any element in this algebra A of V, that means any operator on V, is a sum of a Hermitian and a skew-Hermitian operator.